All right, so now we're going to start another method called the elimination method to figure out where two lines intersect, okay? So here we have two equations, and these two equations represent two lines. And if we were to graph them, both of them would intersect at one particular point, an xy point. And what we're trying to find out is what is the value of that x and what is the value of that y. But we don't have the luxury of graphing, so we need to use only algebraic methods without a graph to figure out what x and y are. We've used the substitution method before, and now we're going to use another method to come up with that x and y without a graph, and it's called the elimination method. And the reason why it's called the elimination method is because we're going to add these two equations so one of the variables is eliminated. Once one of the variables is eliminated, we'll have a regular equation with only one variable that we can solve for. So let's say that these are the two equations that we have. What we can do is we can add them together. If we add them together, then do you see that this positive 3y added with this negative 3y turns out to 0y, because negative 3 plus 3, so negative 3 plus 3 is 0, and so 0y just makes it 0. And so this y variable completely is eliminated. It drops out, and then you have just an x equals something. So let's try that out. We're going to always add these two equations together. So 4x plus 2x is 6x. 3y plus negative 3y is going to be 0y, or just 0, so I don't need to write anything down. And then on the other side of the equation, we have 11 plus 1, which is 12. Now, do you see that I have 6x equals 12? I only have one variable, which is x here. And so I'm going to divide both sides by 6, and I've got x equals 2. Now, by the way, it doesn't matter which of the variables drops out. If I added x and they dropped out, and then I added the y's and they come up with something, then that's perfectly fine. So we can either drop out the y's or drop out the x's. It doesn't matter. In this case, it turned out that the y's were the ones that dropped out. Now that we have x equals 2, so I can put that over 2 over here as 2. So I know what the x value is of that coordinate, so that's 2. Now I can plug 2 back in to either of these equations, of these original equations, to figure out what y is. It doesn't matter which equation I plug 2 back into. Either one would be fine. So let's take this top one. So that would be 4 times x. We now know that x is 2 plus 3y equals 11. So 4 times 2 is 8. 8 plus 3y equals 11. I'm going to subtract 8 from both sides. And now I have 3y equals 11 minus 8 is 3. Divide both sides by 3, and I get y equals 1. Y equals 1. So that was what my y value is the whole time. So I'm going to put that over here. So if these two lines were drawn on a graph, they would cross, and they would cross at the point 2, 1. That's the common solution, or the solution to the system of equations. Okay, let's do another one where it's a little bit more difficult because we actually have to multiply through by a negative 1. I'll show you that right now. So we have 2x. Here's another set of equations. Equals negative 2. And then we've got 3x plus 4y equals 3. Okay, so in this case, do you see that if I added these two equations, neither the x nor the y would drop out? If I add the x's together, I get 5x. And if I add the y's together, I get 8y. Neither of those dropped out. We want one of the variables to drop out. So this is what we do. If we're trying to add the two equations together, what I could do is this. I could multiply one of the equations through by a negative 1. It doesn't matter which one. Let's multiply the top one through by negative 1. And I'll show you what will happen. I'm going to multiply every single term in this top equation by negative 1. As long as I multiply every single term by a same number, then you can do that. As long as you multiply every single thing by the same number, you can multiply an equation through by the same number, and that's okay. We're not going to do anything to this second one right here at all, okay? We're just going to multiply through the top. So if I multiply through by -1, this 2 turns into, so I'm going to distribute this over everything. So this 2 turns into a -2, so -1 times 2 is -2. -1 times 4 is -4, so that turns into a negative. And then -2 times -1 turns out to be a +2. Okay, so I have just multiplied just the top equation through by -1. What was the advantage of doing that? Because it seems like an extra step. It is an extra step, but it makes our lives a lot easier in the long run. Because now look, do you see that this is a -4 and this is a +4? When I add these together, the y's will drop out. So now I can go through, just like in the last problem, and just add the two equations together. -2x plus +3, so we're adding these two. -2 plus 3 is 1, so that's 1x. -4 plus 4 is 0, so we have 0y or just nothing. And then 2 plus 3 is 5. So I have 1x equals 5, or x equals 5. So I'll put that over here as my x value, so that's 5. Now I just need to plug in 5 back into any of these equations to figure out what our y is. Let's do the bottom one, it doesn't matter which equation. So if I plug in 5 for x, so instead of 3 times x, it's now 3 times 5, plus 4y equals 3. Now I have 15 plus 4y equals 3. I'm going to subtract 15 from both sides. So that's 4y equals 3 minus 15 is -12. Now you can divide both sides by 4, and y equals -12 divided by 4 is -3. Okay, so now I can put my -3 where my y value is. And so if those two equations were graphed, they would cross at the point 5, -3. Thanks.